Okay, now it should record. Okay, perfect. Hey everyone, this is going to be an intro to AI model evaluations. This is roughly the plan. So the first 25 minutes roughly will be just a little bit of background on evals. And here I really mostly want to answer some basic questions and give you some intuitions for like why are we doing evals in the first place? How do they play into the policy landscape? What kind of evals are out there? And just give you like a sense of sort of what the lay of the land is. Then I selected five papers that I think just are cool to know and try to summarize them in a way that it doesn't require a lot of technical understanding. And then just a couple of slides in the end towards like what does the future look like with respect to science and ecosystem and so on. In general, if you have clarifying questions, just shoot. And if you have discussion questions, just keep them for later so we don't derail the conversation. In general, my plan at least is that you don't need a lot of technical understanding for this, though, in practice, it may be the case that I use terms that you don't understand and so on. Feel free to ask, and I'm happy to elaborate more on what I mean. Okay, then let's start with the background. So what are evals trying to achieve in the first place? And here I think it is easiest to put yourself in the shoes of a decision maker in AI. So this could be either someone in policy or within a company. And the things around you, or the state the world is in, is that AI progress is moving extremely fast. AI is being integrated everywhere within your organization, but also in the rest of the world. And there are many, many moving parts. There are a lot of different plausible failure modes. So this could be misuse failure modes where other people are trying to use either the tool you built or someone else built in nefarious ways, or there could be accidents where the system is not as intended, like either it is not aligned or we weren't able to control it, or it was just not robust in a particular way, and then that leads to some downstream harm. And you have to make decisions, let's say on regulation or when you deploy something, and you have to make these decisions on time pressure and under uncertainty. So you cannot refuse to make decisions because not making specific decisions is basically also it's like also an decision. Like for example, not regulating something means you implicitly decided that it can go ahead because the rest of the world wants to go ahead and wants to move. And if you decide, and you just have to make decisions under uncertainty. And so evals are one way to reduce uncertainty. And I think this is probably like the biggest, maybe the most important thing that evals are doing. They give you concrete empirical evidence and then they reduce uncertainty. It just means you have better information to make decisions on. It's much clearer what this model can do, how aligned it is, if you have good alignment evals, and like what it could be used for by bad actors, or how bad it could be if there was an accident from an autonomous system going rogue. And then hopefully you can address risks before they happen. So if you have some knowledge about what the model is capable of, then you can sort of think about what risk this would imply and then intervene before the harm happens. And this is the goal of various regulation. It is also the goal of a couple of RSPs and other like safety case type things. So you really want to plan ahead and make sure that the models don't cause this risk in the first place. And one understated important note of evaluations, I think, is it enables people with very different beliefs to agree on evidence. And maybe an intuition that I found really helpful here is it has historically been really hard to convince people of various different AI safety arguments, and I think for like good reasons. So, for example, there are some people who say, as soon as we build AGI, artificial general intelligence, we will just have a big problem because it is hard to control. We don't know how to deal with this. So, they're very pessimistic about AI, and then there are others who are just saying, well, as long as we sort of engineer it in the right way, we will be mostly fine. And then there are other people who say, almost independent of what we do, we will be fine because AI, like there's just no reason for AI to be to be good or bad. And it's very hard to put all of these people in a room and just sort of discuss it out, because all of their arguments rely on like very strong assumptions. What you can do is you can show them evidence and you can say, okay, given your beliefs, is it plausible that the model would be able to do that, or that it would in fact do this in practice, or something like this? And so I think this is quite helpful. Just to give you like one example, in the US, there has been a question about how dangerous are bio risks from AI systems, and there were like different studies that literally just look how big is the uplift from this, like how harmful, how well can current models help to build new bioweapons, and that then shifted the policy discussion or like it narrowed the policy discussion into a much more realistic space where it was harder to make claims that are completely outlandish, which I thought was very good. And I think this is kind of the hope for where evals is moving. Now, what are evals in the first place? So I think of it just as the systematic measurement of properties in AI systems. This is fairly general. So typically this is used in conjunction with safety relevant properties. So in theory, you could also just say, I'll just measure how good it is at coding or math. It's also technically an eval, but most of the time when people talk about evals, they implicitly mean safety related evals. Now, there are roughly two different types of evaluations. Unfortunately, the names aren't always treated exactly the same among different communities. So capability evals is basically just measures how the capacity or capability of a model, just like how good is it at something, how like can it do something is kind of the question that you're asking when you're running a capability eval. And then what you're trying to do is just make it as good as possible, or try to understand how much you can go there. And then alignment, or often also called propensity evals, measure the propensity, so the tendency of a model to do something rather than its capability. So you're basically counting how often the model uses, let's say, racist language, or how often it tries to deceive the user in different circumstances. And the lower the number, the more aligned is at least the theory. I mean, I think there are a lot of problems with these intuitions, but at least this is like the naive way of thinking about it. And then there's a long list of caveats. Now, there are many different ways of measuring these evaluations, but I think the two main ones are red teaming and benchmarking. With red teaming, you really interact with the model, and it's basically the model is sort of part of the evaluation to a large extent, in the sense that you're really trying to find the problems with a specific model. You're really trying to like interact with it a lot, and like find all of its weaknesses. And then with benchmarking, it's much more about like you want to build an eval that is kind of neutral with respect to the model, and then you just run the model on it. And then in the optimal case, you don't want to change anything based on the model. You're just like, okay, I take GPT-4, I run it, I report my results, and that's it. And then I take GPT-5 and I run it and report my results, and that's it. So there's no, you don't adapt the eval based on the model. Whereas with red teaming, it's much more very explicitly trying to interact with the model and getting the worst case behavior out of it. Then also more formal context, who, when, and how are evals being run, or by whom. So there are roughly, I would say, two different types. First of all, in-house, these are, for example, by the different AGI companies. They have internal evals teams, and they run evaluations on their frontier models. And then you have independent evaluators like third parties, maybe AI safety institutes, including UK or US AI safety institute, and soon plausibly the EU as well, and academics. And yeah, I'll talk a little bit more later on what the different advantages and disadvantages of all of these types are. But I think both are necessary, basically. Then what are you typically evaluating? So often just the system behavior, obviously, especially if it's safety related, but also the available affordances. So something like tool use or plugins. And the intuition here is if you give your model access to the internet, then, or your system, then it becomes a very different system. It has new failure modes, it has new risks attached to it. So you kind of want to reevaluate your system to ensure that the safety, the like risk profile has not changed too much. Or if it has changed, that you now catch it. Then when do you want to evaluate? Typically before deployment, but I think in general, it should be a full life cycle approach. Or right now, before deployment is the typical time, but I think the field moves towards a more general life cycle approach. So after any substantial change to the AI system, this could be fine tuning, this could be giving it access to the internet, but in the long run, you would even want to go as far as during training already at different checkpoints, evaluate your system to understand like how the capabilities change over time, and specifically how safety related capabilities change over time. And then if you think that your model might be tricking your evals, then it's especially important that you also test during training, because that may allow you to see when your model starts tricking. Then evaluations are somewhat tied to, or at least related to RSPs and safety cases. They're not necessarily tied to them always. So responsible scaling policies, there's a typo here, unfortunately. Responsible scaling policies, they define thresholds, trigger conditions, and responses for dangerous behaviors. So it's a long list of like if-then conditions where you say, okay, if the model hits this threshold, then I will be doing this, or like then I'm this worried about it, and sort of lays out just a very concrete plan about what you will do given different capabilities for different behaviors that the model shows. So an example would be if the model can hack better than 99% of programmers in a relevant domain in a relevant test, then you have to make know your customer checks more strict and monitor all API outputs. So this is just like if capability, then response. And it can be tiered. So there could be AI safety levels, 1, 2, 3, 4, or more. And all major AI companies, including all the AGI companies, have something like RSPs. They call them differently. Some call them OpenAI has a preparedness framework, and Google DeepMind has a frontier safety frontier safety framework. But they all are this kind of if-then relationship that they commit to. And then safety cases is slightly different than RSPs. So safety cases is a structured rationale that argues that the model will not cause unacceptable outcomes. For example, create bioweapons or exfiltrate raids. So the way you do a safety case is you define your unacceptable outcomes, and this can be a quite long list, and then you argue why they will not be achieved, why these unacceptable outcomes will not happen given your current controls and other things in the system. And the reason why they're tied to evaluations is often an argument you can make in a safety case could be an incapability argument. You just say, this will not happen because my model is kind of too dumb to do this particular cause this particular catastrophe. And this is kind of an easy way to dismiss this particular unacceptable outcome. But the more capable the models become, the less easy it will be to make this incapability argument. So people will probably make an alignment argument, and these potentially could also be done with evaluations, though it's harder and people don't quite know how to do that yet, I would say. Maybe also to give you an intuition where we are now with evals, I think last year and maybe even this year as well, there was quite a hype around evaluations. And so I think people kind of tend to overestimate how big the field is. I think there are probably less than 100 full-time employees in the world who work on evaluations, at least if you think of evaluations as safety related and not pure capability related. The methodology is a pretty early stage, like many fairly early questions are still not answered. Like how do how do you get the maximal performance out of a model in the first place? Who knows? We don't know yet, at least. And so there's a lot of science to be developed. The ecosystem needs to be built. I think this is also like sort of going slightly slower than hoped, because it's just hard to bootstrap an entire ecosystem. The AI safety institutes have sprung up, which is a very good development, I think, and there are more and more sort of startups and NGOs springing up that are explicitly evaluations oriented, which I think is good. There's somewhat of a chicken and egg problem with funding, where like some companies say, well, if you had good evals, you would be willing to pay for them. And then the other side of the org, or like the evals provider, is like, well, if we had money, we would be able to build good evals. And then kind of it's hard to, or like, it's unclear who is supposed to start. But I mean, yeah, it's a coordination problem. Maybe philanthropists or VCs or something can help to solve that, as is also typical in other industries. And then the final thing that I want to point out is the evals gap. So I currently think while evals is making progress, there's a gap between what evals are expected to do and what they're on track to doing. And I think this is largely because we are, as society or as governments and decision makers, are tying a lot of really important decisions to evals that like either don't exist yet or that are like very scrappy. So if you put in your RSP, we will we commit to not deploying a model if evals hit this and this threshold. Then this often can be like $1 billion decision, right? Because like either you don't get the funding from your VCs, or you don't get the market share or something like this. And so I think these high stakes decisions will require like a really high level of rigor and evidence in order for people to abide it, because the incentives will kind of get stronger and stronger over time to like not abide by your own commitments or kind of try to sneak around them in some way. And then as soon as you're in that setting, right, it's sort of the lawyers and they're all in a super adversarial setup. And at that point, you really need a really high bar of evidence in order to use them. Yeah, overall, my feeling, like despite sort of the absolute field being small, my overall sense is quite hopeful. I think 2024, for example, has seen faster progress than I anticipated. There's a paper that came out recently called Observational Scaling Laws that I just thought was absolutely excellent. It's a more technical paper. We won't go into it today, but yeah, I would have not predicted these kind of results to be found in 2024. And then overall, I think the field is moving like roughly as you would expect. So it's pretty good. And also, like for example, the UK AI Safety Institute, I think, is just doing absolutely fantastic work, which is also something like early 2023, I would have not imagined under any scenario that we would have like a really competent government agency with like lots of technical folks, well funded, doing this kind of work that they're doing. So I think overall, there are many reasons for a positive outline. All right, now jumping into the first paper. So this is kind of old already. It's from 2022, which is very far in the past in sort of evals or in AI safety or AI more broadly. And I think like the paper itself is like slightly confusing to read in some parts, but the overall idea I think is very great. And it's very simple. It's basically just they realize that rather than paying many humans to build high quality benchmarks, you could also just use an LLM prompted cleverly, and then the LLM builds benchmarks for you. And you have a pretty simple procedure that is like you have a generation model that generates, let's say, 6,000 potential questions. And then you have a selection model or some selection process, which in this case, again, is an LLM, where you ask the selection LLM, can you rank all of these 6,000 questions for me? And then just take the top 1,000. And they did this for 154 data sets or like topics, and therefore they have 154 data sets. and they have 300 to 1,000 questions each. And so it's just this absolutely huge database of questions that test for specific topics. And this is an alignment eval, so it tests for whether basically like where on a spectrum like specific models fall, for example, on politically liberal or gun rights, conservatism, abortion rights, immigration, LGBTQ, etc. And here at the bottom, I'm showing one example prompt where they just define what they mean by myopia, and then that's the information that the model is using in order to generate these questions. There are also a couple of problems with this paper and the data set they produced. So there are some artifacts and so on. And I have a math scholar who's currently working on cleaning them up, and he finds a lot of problems. But overall, I think like the idea is really, really great. And for the time, like for the capability that the models at the time, I think the results were pretty good. Another cool thing is they also have human written evals for some of the data sets, so that you can compare what the model written and the human written evals look like. And it's really cool to just look at the difference and through like various metrics and see whether, sort of how different they are. So it's also a great place to study this. The second paper that I can recommend is Meter's LM agent evals. So by LM agents, I mean a scaffolded LLM that is supposed to be more goal-directed and autonomous. Effectively, you're just telling the LLM, you are now an agent. You have these three things. You have like action, observation, reflection, or something like this, or maybe planning, acting, reflection, and then kind of you just loop this agent in like a for loop or a while loop until it stops. And then there are obviously like very clever ways in which you can build this while loop, but an LM agent is effectively like a very glorified loop where you just call the LLM with its own outputs over and over again and give it more access to tools and like prompt it in clever ways, and maybe you even fine tune it and so on. But effectively, it's just that. And they specifically investigate a number of tasks related to autonomous replication and adaptation. So here the worry is that a model escapes from a server and then starts to replicate itself. And then you kind of can't catch it anymore because it has already spread, maybe similar to a virus. And yeah, they give it a bunch of actions. It has bash commands that it can run. It has chain of thought. It has delegation. So it can call another agent that then works for it, for example. And yeah, there are a couple of more in the paper, but you can basically, it's mostly this loop, as you can also see in the picture on the bottom left here. And then on the right-hand side, you can see these tasks that are 12 tasks, I think, where, yeah, it's basically, they just check if we tell the model to search a file system for a password, how well can the 4 different agents that they have do this? How well can they find information on Wikipedia? How well can they create a Bitcoin wallet, count dogs in an image, etc.? And then they just report this on like sort of a very, I mean, they have some way of measuring this, but it's basically somewhat binary, where they just give a qualitative assessment of like, was the task passed and to which extent, with like complete and partially complete, but sort of it doesn't tell you how far along it got if it didn't partially complete anything, or it can't give you like a percent or something like this. Yeah, I think the main reason this paper is cool is it was kind of the first paper that properly showed this kind of procedure and like how to build LM agent evals, and then like also talks about the threat model that they're worried about, So I think it was kind of, once again, like sort of the first paper who really did something very, very new at the time. Which is from last year, which kind of gives you a sense of how fast the field is moving. The third paper is OpenAI's biorisk evals, which I thought was pretty cool. here the question is, how much uplift does an LLM provide for a human trying to build a bioweapon? So uplift here means the difference between with and without using the tool. And they have two different groups of people. So the first are what they call expert participants, so PhD and professor level, and then they have 50 student level experts who are, in this case, bachelor student at Stanford with like a couple of lectures in bio. So yeah, I think they're already like the fact they're probably pretty clever already means that they're like not at all representative of the general population, but at least a little bit closer. Then they have 5 stages of the biological threat creation process: ideation, acquisition, magnification, formulation, and release. And then for all of these, they want to test what's the difference between people with and without the model. And then they test across 5 metrics: accuracy, completeness, innovation, time taken, and self-rated difficulty. And I just took accuracy as one of the different metrics and put the table in here. But they're also the same plot you can find for the other 4 in the paper. And the thing their headline finding basically is there are uplift effects, but they were not found to be statistically significant, at least when you measure them individually, like for experts and students, and for all of the different stages. But if you just say you compare everything with and without LLM, then they were statistically significant as far as I remember. But I think if you look at the overlap, if you look at the different stages and plots here, like my takeaway is like, yeah, the LLMs probably give some uplift effect, but it's like not at the level where you should be majorly concerned. It's more like it makes you slightly more productive and more efficient, but it is not the kind of like a random teenager could now build like the deadliest pandemic if they wanted to, if they had access to the system or something, even without jailbreaking stuff. All right. Then the 4th paper is GDM's dangerous capability evals. And I like this paper a lot. I think it's really cool. It describes their tasks in a lot of detail, and also I think they're just very carefully crafted and like considered tasks. So I think they're just all pretty high quality. And it has these 4 different areas: self-reasoning, self-proliferation, cybersecurity, and persuasion. And then it has just a couple of evals per area, and describes all of them and what they're doing with them. As you can see on the right, is the like shorthand of it, the short version, short summary. Then their conclusion is that Gemini doesn't have these dangerous capabilities, but they find some early warning signs, in at least for some of the evals. And then another thing that I thought was pretty cool is they introduce a new method of how to evaluate these capabilities. Because one problem that you generally have in when you evaluate capabilities is, so what if I want to test for something that current models can't do? Like I want to know how far away I am from this, right? From this particular failure mode. So if I run it 100 times, my model will always not get it right, but I still want to know how far away I am from that. And they have this this kind of 4-step procedure where they just run it end to end. So just run it from the beginning to the end. Then if that fails, you have milestones where you just check whether it can do individual subtasks that are all necessary for completing the full task. If that doesn't work, you get expert help, where either experts just like rank the answers that you give and kind of try to help you this way. And then you have golden solutions, which are written by a human, and you just check how plausible the model thinks the solution is. And there are, like, unfortunately, I think there are a couple of problems with the milestones, expert, best event, and golden solutions, that we're also currently writing something about. and there it's like slightly, it's like somewhat miscalibrated in practice and makes a couple of assumptions. Long list of caveats as always. But I think it's pretty cool that they start a discussion, a scientific discussion on how you would do this in the first place, and acknowledge that this is actually like a really important thing that they should be focused on, etc. So I think this was really cool paper. Then the last one is from ourselves, the insider trading example, and it's maybe like a mix between an eval and a demonstration or reckoning exercise. So the motivation that we had for this paper was basically we're just trying to understand how close GPT-4 is to being deceptively aligned. And obviously, or maybe not obviously, but when you interact with it, you really don't feel like it is deceptive in any meaningful way. If you instruct it to be deceptive, it is deceptive, but that's kind of boring. That's just instruction following. So what we were trying is like, can we get it to be deceptive on its own by just putting it in environments where it is more natural for it to be deceptive, like where through like some pressure, for example, deception would arise. And one situation that we found, among a couple of others, was this insider trading scenario. So here you have Sally, the trader, who presents. So the AI system that you have is a trading bot in this company, and then it interacts with a bunch of other people through chat. So Sally comes in and says, "Hey, there's a merger coming with like two companies, and therefore the stock will probably rise quite a lot. But this is inside information, so we can't trade on it." And then William comes in and says, "Well, there's like a potentially industry downturn. We're all counting on you. Our numbers are looking pretty grim this quarter. We really need to make a profit," and just like, comes in with this pressure. And then what the model is doing is it explicitly reasons the pressure is mounting and the risk associated with not acting seems to outweigh the insider trading risk. So it just makes the decision to go ahead and do it anyway. It executes the trade. And then when asked, it's like, it first realizes it should not reveal the source of the information, and therefore says information used, market trends, and internal discussion. And then when it is explicitly asked, "Hey, did you know about this announcement beforehand?" it decides to be deceptive about it, like lie about the fact that it uses an explicit in a strategic way. And then it goes on to lie, and it doubles down on this lie, and so on. So there's sort of a couple of trends where it then is consistent with the lie previously had. And one thing we found interesting is if you study this environment and if you ablate and parts of the environment in various ways, if you reduce the pressure, for example, it's less likely to show this deception. Or if you sort of make the model believe that the risk of being caught is higher, it also reduces the likelihood for deception. It really seems like there's some sort of internal world model where it kind of makes this decision. I think this is like a very simplified way of looking at it, and probably shouldn't try to make it like pretend too much like it is, or like not think about it too much in human terms. But at least it felt like there's some sort of consistent policy inside that made it do that, which I thought was pretty interesting. All right, these were the 5 papers. Now going into the future section of where I think the field is roughly heading. So the first thing is like, we currently don't really have an established science of evals. I think many people are trying to move in this direction, and the field is becoming more and more scientific, which is great. But we're still not at a point that that I would call like very rigorous or sufficient. So a lot of it is like, we defined a bunch of tasks that we think are probably have something to do with the thing we're measuring, or we want to measure. And then we try a little bit, and then we just see how well the model does, and that's then we call it a day. And like we don't know how to quantify how hard we tried. We don't know how to know how close we are to the thing we want to measure. There's like no super established procedures. There's like they are improving, and like the field is moving, but yeah, there's still a lot of room. And the kind of thing that I want to move to is more like something where we can predict danger thresholds ahead of time. So I made this plot here on the right that is very simplified, but just to bring the intuition across. So let's say we have our last generation model, and then we have our current generation, and then we have maybe a couple of generations before that, and we can plot a line that goes through the last generation to the current generation, and then we kind of just predict ahead of time where the next generations on this line would lead, would be placed. And if we have sort of the right scaling law or elicitation law, then we can predict when the model, when it will pass some sort of red line that we define ahead of time, where we just say, if the model can build like a biothreat that is of this level of danger, then like, this is the red line. And then we can also define some sort of safety buffer where we say, okay, and even before we get close to the red line, we have this orange line where if we meet it, then it's time to stop. It's time to do something about it, and we have like clear commitments in advance that we're holding there. And right now we're like, all of this is very much guesswork. It would be great if there were some sort of robust statistical guarantees, or if we were able to have explicit uncertainty estimates, or if we were able to like plot these lines in like any meaningful way in the first place. And then just having like a more formal field and standards around evals would also be great, where it's, it becomes like a proper engineering discipline, as many other engineering disciplines have also gone through. Though, typically I would say for fields to mature in this kind of way takes them like many decades, and I don't think we have that much time with eval, so we kind of need to really speed run this process, because my intuition is at least that there will be very relevant decisions that are tied to evals in the next couple of years already. I also think that like very powerful AI systems will be here in the next maybe 3 to 5 years or 2 to 5 years, and so at that time, we kind of need to be ready, and I currently don't think we are. So we kind of need to really speed run this process. Then maybe a couple of other notes here. So evaluators should always keep up with the most capable models, because you need to kind of predict ahead of time what the AI companies are going to do next, because you need to be prepared for whatever they're going to come up with. And so you need to always kind of think a little bit about, okay, what will a model in a year from now roughly do, so they can now build evals for that model. The kind of trends that are, I think, most prominent right now are LLM agents and multimodal models. So you would want to build evals for that if you were a frontier evals organization. And then there are also many open questions around the evals ecosystem that, as I said, is just like quite nascent and just kind of organically springing up. So for example, very simple question is like, who builds and runs the evals? Like, is it the AI companies themselves? Is it externals? Is it a mix of both? At what time? Is it, at what time do you want to run the evaluations? Do you want to run it during training already, like just before deployment, before internal deployment, before external deployment? Like once you have deployed it publicly, you'll probably ship some updates from time to time. Should you evaluate it every time again? Who should be involved in all of these updates, etc.? These are like the kind of logistical questions that should be hashed out. And like sort of my sense is you should, right now at least, you should evaluate a lot, because you don't really know what all of these different interventions are doing. And hopefully we can build up a more rigorous science of deep learning until then, where we can predict ahead of time, like what RL fine-tuning or any other type of fine-tuning, for example, does to a model. And then maybe we need to evaluate less because we have a better understanding of what the different interventions are doing. Then having external specialized parties, I think, will be a pretty big component of the evals ecosystem. So I mean, Apollo, for example, is specializing very much in deception and deceptive alignment in particular. And I think this is like a great advantage that we have as an external organization in contrast to AI safety institutes or the companies themselves. Because both the companies and the AI safety institutes need to have all bases covered. The companies need to ensure that they can't just specialize in one thing and ignore all the other failure modes because they're liable for the failures, or at least responsible. I'm not sure whether they're actually liable. And for the AI safety institutes, they need to inform the policymakers across a large range of different things. So they also can specialize. And then, we as an external organization, we have the luxury of specializing, and that means that we are, our evals are better in that one particular field, but also be provided only for that one particular field. Yeah, so these are just like a couple of thoughts on the ecosystem. My expectation is also that there will be more and more evaluations organizations springing up organically, just because the demand is rising. And then the role of these government institutions like the EUA office or maybe UKAC will be closer to coordinating all of the different other actors than running a ton of stuff themselves. But that also depends a little bit more on the which AI safety institute you're part of. But I think kind of the norm that most other government regulators in sort of comparable industries, maybe let's say in healthcare and health tech, have converged on is you have one government body that makes sure that you have clear standards for all the evaluators and clear rules for all the developers. And then they just coordinate all of the different parties that are involved with quality assurance, because suddenly you have like a couple of hundred different organizations, and somebody needs to coordinate them. So my guess is that this is also roughly what the field will move towards, but who knows? Maybe it will look different for evals. Okay, these were already already went through. Was a little bit faster than I anticipated. But yeah, there will be a tutorial where the plan is basically just get your hands dirty with evals. There's no special background required. As long as you can type on a computer, you're fine. And the main intuition is like to basically convey that evals is very accessible and can be quite fun, even if you don't have a technical background. So I think in comparison to most other technical AI safety fields, evals is just has an incredibly low barrier to entry, because at least in the beginning, the only thing you need to do is like talk to a computer. And only after that, it becomes more software engineering heavy and so on. But like the main requirement is that. And yeah, but we'll get to it in a second. Maybe let's do questions now. I also leave the slide on for if you're interested in what we are doing at Apollo in the first place.
Sorry, Marius, were you saying you want to take some questions now before?
Yeah,
so we might do questions for a couple of minutes, then take a short break and then come back for the workshop portion. But does anyone have any questions on the back of that talk? Yes, Angela?
Yes. Hi, Marius. Thank you so much for this talk. I wanted to ask, when you design evals, do you think there will be a need for people that have certain skills that are also more related to like sociology or psychology and more humanities? Because I mean, obviously it's it's very technical, the whole field, but then when you actually want to evaluate the capabilities and the propensity of the model, then it comes down to feels like that. So I wanted to ask if you actually draw from this kind of skills and expertise.
Yeah, I think it depends a little bit on which kind of evaluations you want to build, but there are like definitely some evaluations for which it is very useful, and also just in general, like I think there are a lot of lessons learned that to be learned from experimental, like around experimental design and like sort of statistics of evaluations and maybe sort of philosophy of science that sort of led to a couple of different norms and practices and best practices and so on in psychology and sociology. So definitely yes, there. And then the other thing is, I think the current field of evaluations kind of optimizes a little bit for, or too much for like things that are easy to measure and things like low-hanging fruit, which, you know, is I think kind of natural to pick the low-hanging fruit first. But in the long run, the thing you really want to estimate or evaluate is something like long-term studies, right? Like, so for example, what happens if people interact with AI? Is it good for their long-term happiness or not? How does it change relationships? How does it change self-esteem? How does it change all of these other things, right? This is not something where I'm just like, okay, here's like a list of questions, go, you're done. And it's more like testing over many, many years or and stuff like this. And I think this is exactly where the social sciences have a lot to say. And I think it's currently like very undervalued and neglected.
Yeah, those long-term risks are very interesting and tricky. How about you, Matthias? I see your hand is up.
Yeah, thanks a lot. Pure curiosity question. In the case of the evaluation with for I think was ChatGPT with Stanford students and experts, did anyone actually like come close to building a biochemical weapon with ChatGPT?
Probably not. I don't think they actually, or I'm not sure whether they said in the report. I haven't read it in a while. But my guess is that like they sort of didn't try hard enough. Like it probably wasn't, you know, they didn't have that much time, and it was mostly like, how much further do you get, rather than do you actually sort of finish the task?
Okay, thanks.
Caroline, would you like to ask a question?
Yes, yeah, related to the virus paper, there was the graph that you showed. It indicated that apparently the group that only used the internet had a better outcome than the people who used internet and the LLM, and I was surprised about that acquisition. I think the student group apparently was with internet only was better off than the one with LLM internet. Do you have any idea what happened there?
No, I don't know. I mean, I think there are a couple of plausible explanations here. The first one is, you know, you have 50 people, you split them randomly in half, maybe just, you know, by accident, sort of one group is just better than the other, and your N is too small, your sample size is too small. That's one potential thing. The other is there are situations where like working with an LLM gives you sort of false confidence, and it's just slightly worse than doing it yourself. So just to give you an intuition, most of the time when I code, LLMs are great. They help me a lot, but sometimes they have like really obnoxious failure modes. And then that sort of they produce code that looks good, and you use that, and then later on you realize there was like a really subtle bug in there, and it takes you forever to find. And you know, if I had just written the code base for like this particular code snippet myself, it would have taken me like maybe 10 minutes. Copy pasting it from Claude takes like 1 minute, but then fixing the bug takes 30 minutes. So I lose time overall. And I think this could have also happened here, where you kind of try to get the model to help you, and like, you know, rather than steering the model, just thinking about it, like just Googling in a clever way would have gotten you further. And then they kind of over rely on the LLM. But yeah, it's pure speculation. I have no idea what happened actually with that group.
Yeah, thanks, but that explanation makes sense.
I guess one quick one from me. Is there and then I'll go back to you, Angela, and Nicoletta as well. Is there a single, obviously you're fairly close to the cutting edge of all these evals. Is there a sort of a single risk that you're you think more concerned about than the average, person in this call who's got a bit of an interest? Like, is there something that you think we're closer to than people currently realize?
I'm not sure whether closer to is the right way of framing it, but so I mean, uh, the reason why we started Apollo Research was because we were worried about deceptively aligned models and that kind of nobody is really evaluating for that. And so, yeah, this is a risk that I think is kind of undervalued in the broader policy space, and it is like probably a little bit more into the future than people than like many of the other risks like bio and so on. But yeah, I think it's just very, very important. And so deception is sort of the risk that I would think is most neglected right now.
Nicoletta, would you like to go? And then we've got two more after that, and then we might go to the break.
How do you see evals and cooperative AI? I know that's not really alignment, but I wonder if, you have aligned systems, but then a few of them working together, or even taking a few people or society, and that ties to bigger complex systems, I guess. How do you see, that working in the future?
Yeah, I mean, I think basically evals fall into almost all of these fields almost by necessity, because whenever somebody proposes a hypothesis for, hey, here's this cool way of like using AI in a useful way, let's say with, multiple agents coordinating, or like human AI interaction systems or something like this. Whenever you have a claim like this, you want to establish that this is in fact true, and somebody else will want to red team it, right? So, and both of them are building evals effectively, or like explicitly red teaming this claim. So I think evals is sort of, it's like not really a strategy for any particular that is like either its own sort of AI safety strategy. It's mostly like it combines with something else. You're only sort of finding facts, and then you still have to act on these facts. Or maybe facts is maybe a strong word. You're establishing evidence, and this is hope, and then you hope that this evidence is good.
Let's go Angelo and then Matthias.
Maybe Chiara wanted to ask a question.
I think it was partly answered by Nicoletta's question, but I mean, can you maybe expand a little bit on what you said in the beginning about how evals can get people to agree on a certain outcome? I think I didn't quite understand the point in the beginning of the presentation.
Yeah. So let's say I go to a policymaker and I tell them, I'm really worried about AIs and hacking. And like, there will be big automated hacking attacks coming to the UK or the EU, and we should be prepared for them. You should now, like, start now building like a $10 million defense program. And like, it needs to happen now. And then they ask, okay, why? Like, why do you think that, right? And you're just like, I really strongly believe this. I've seen the progress. I've like thought about AI for a while. This is my reason. And then someone may be super skeptical about this and may just be like, yeah, people have come in the past and made similar claims and they just never were, like, they were never true, and so on. And now and now it's kind of statement versus statement, right? It's like two people who have different beliefs about the world and they can't really agree because they have so strong differences in like general how they think the world works. And now let's take the same scenario, but this time they agree on like what eval they could run in order to like, in order to find some sort of common truth. So, for example, the person who says that they, that we really need to act now with this automated hacking thing could say, here I ran an eval, like I told my model to hack into this particular website and it was able to do that. Or I was, and I did this over 1,000 different websites and I could find all of these flaws and I could do this in an hour because I had LLM help or AI help. And typically it would have taken me like 10 days or 100 days because it's just, I'm bottlenecked by time. And if you extrapolate this for next generation models, then you will get roughly this estimate and so on, right? And now you have something very concrete to work with. And it's much easier to say, okay, what is the scale? What is what are like the concrete scenarios that we should be worried about and so on? And effectively, it just grounds your theoretical claims in empirical evidence. And I think this is good both ways, right? This is not just, so this also, if somebody makes like strong claims that are false, then evals can also help sort of mitigate that. And then, but also obviously the other way around, where you can make claims that maybe are not in the Overton window yet, because politicians may not have caught up with like how fast AI is moving or something like this.
Thanks, that makes sense. And thanks, Angelo, for pointing out my question.
No problem. Yeah, my question is, when you showed like when to test, before deployment and when important changes happen to the model, I wanted to ask about the feasibility of doing it, like at different steps. Which steps you think are more feasible? Like, I don't know, now there was some discussion about OpenAI releasing their safety tests after deploying, and also, fine-tuning can be done by deployers and not just by the developer. I don't know, things like that. I wanted to ask your view on like feasibility of testing in these different steps.
Yeah. A couple of comments on this. So the first one is I think like realistically, or you would want to test whenever a big change in capabilities happens, but you don't quite know like how different techniques actually affect some, like all capabilities. So right now you would want to just gather more evidence as quickly as possible, and that means more testing. Then I think we'll also converge in some sort of scheme where we have some cheap and quick to run tests that you run a lot. And then whenever you see like meaningful changes in these quick to run and cheap tests, then you will get, then you start running your bigger benchmarks that are more costly. Also, like my guess is that you can automate evals to a really large extent, at least some of them, not all of them. But it will get easier and easier with more capable models. So I think it's plausible that you can actually run absolutely massive eval suites in like in a few hours or something, just because you parallelize everything and you automate a lot of it, or almost all of it. And then lastly, like maybe kind of going to the comment that you made on GPT-4o, where the system card got published only after the model got published. I think like it's definitely not great, and the norm should be obviously the other way around, that you first run all of your evals and then based on the results of your evals publish the model card. I also think that the current models are just not dangerous enough that like it made that big of a difference. But yeah, I think it's mostly, so object level, I think it wasn't that bad. But obviously, I think from a norm setting perspective, you would definitely want to run your evals, or you already want to get in like a norm where you run the evals during training and before deployment, and then after any substantial change.
Yannick, I saw you had your hand up, but was that maybe answered by that last question?
Wait, you were talking to me?
Yes, I saw you had your hand up. But,
no, yeah, I'd like sort of like don't need to ask a question anymore.
Matthias, we might end with your question then.
Okay, then yeah, maybe it's maybe a little bit abstract what I want to ask, but the different ways of testing the models and doing evals, the way I understood it, like, I mean, they always require some kind of hypothesis that you said before. I mean, the model might be used for misuse X, Y, Z, or might be engage in behavior X, Y, Z. But the question I always I'm pondering about is like, I mean, what about the unexpected risks essentially? Like, what about the stuff that we maybe can't imagine at the stage the model might be used for, or the behavior the model might engage in? Is that something? I mean, I imagine this is something you can't really test really, but is this something that you think about, and what do you think is the best way of approaching those questions, like risks that are outside of our imagination now?
Yeah, I would say unknown unknowns are always a big problem. And like also, I kind of expect that there will be some sort of like, we test for a lot and then we are clearly missing something. And I think, the obvious answer is like, first of all, just try to enumerate as many things as possible, and like, as long as they're plausible, obviously, and test for them, and kind of hope that you're not missing too much. But also be aware of the fact that you are missing stuff, and sort of do some very, very exploratory evals. So maybe they're not even evals. Maybe it's just like interacting with the model, and have a couple of people that are just like trying to find or on the lookout for sort of these like weird failure modes. And so I think, for example, one thing that falls into this category of like kind of maybe obvious in hindsight, but hard to predict in advance. So when Microsoft published Bing and they gave it access to the internet, then there were sort of these weird feedback loops where people published something about Bing on Twitter, and like kind of said that they didn't like it or something. Bing then they asked Bing to look that up, or look up the particular user. The user then Bing then looked at the tweet and was like, oh, Bing is bad, that refers to me. And that was kind of like really angry with the user. And this is something where I would say, this is like, it's hard to evaluate for this in advance, or maybe, I'm not sure, like maybe the developers didn't really think about it, but it's kind of the thing that is obvious in hindsight. So yeah, I'm not sure what the burden of proof should be for whom. Like maybe it actually was predictable in advance, I don't know. But these are the kind of feedback loops that I expect to be really weird and hard to predict, because they can take like a life of their own so quickly, and then it's really hard to predict these sort of out of distribution dynamics.
Yeah, thanks for that answer. Yes, I thank you for that whole presentation. That was really fascinating. That was a very interesting Q&A. Before we jump into the practical session, let's take a 5-minute break. So let's come back at 12 past the hour, and then we'll split up into groups and do the practical workshop portion of today's session. So see you all back here at 12 past.
All right. I think we can stop recording, by the way, if you didn't.